Howdy and welcome to the show. Smartphones, very important these days. They do a hell of a lot. We use them for everything from navigation, banking, web surfing, YouTube, making calls, texts and so on. So the downside with a good smartphone these days is that the batteries don't last all that long. Maybe a day, maybe 2 days, depending on how you use it. So what happens when you don't have access to a wall outlet or you've lost your charger? What options have you got? Actually quite a few. Let's have a look. So the first thing to take note of, most of these chargers, so this one here is for the HTC smartphone, and most of these chargers have a USB port, very convenient, and nearly all of them will stipulate 5 volts. Let's just zoom in on this one. Okay, yep, you can see it there. Beautiful. So the output on this particular charger is 5 volts at 1 amp. Great. So if we took another one, this is actually a iPad charger. So this is a 12 watt unit, but the output is still stipulated just down here, 5 volts at 2.4 amps. And yeah, this one's actually not a phone charger. This one's actually for a Bluetooth speaker, but again it's got the standard USB output, and if we take a look on the specifications on this unit, output is 5.0 volts at 0.7 of an amp. So the thing to note there is that all of the outputs on most things with a USB plug, something nice and convenient, is 5 volts. The amperage will vary, but most of the time the voltage is 5 volts. And you've also got, with most of the phones these days, whether it be an Apple device or whether it be something from Android, most of the plugs have either a micro USB or some sort of proprietary plug, but on the other end it's nearly always the good old USB. So that means all we really need to do is get 5 volts to the bottom half of this cable. So how do you do that? Well, the power's gone out, you don't have a wall plug, whatever the case may be. Your most obvious option is a laptop. If you've got access to a laptop, those ports on that USB, the USB port for which you can just plug in your cable, is 5 volts at about half an amp. And I know that we saw the rating on this particular device here is 1 amp, but that's assuming that it's going to charge the battery quickly, and it's assuming that you're probably going to be running the device whilst charging the battery, and it needs an amp to do that. For the most part, unless it's a seriously large smartphone, half an amp will get it up and running. Either turn it off to put a bit of charge into the battery and then turn it on and use it, or use it as it's plugged into the external power supply, such as 5 volts from a laptop. Okay, so what if you don't have access to a laptop that's got some charge, and like I said before, you don't have a wall charger, or you've got no power where you are? How can you get power into a smartphone? Well, in the USB cables, and the reason that the USB cables are so convenient is you can almost pretty much assume 5 volts going through to the smartphone device. In each USB cable, let's take a look inside there, there is typically 4 pins, right? And one of those is positive voltage and one of those is ground or negative voltage. So all you really need to do is hook up external power, a couple of wires, plug this into your phone, hook that up to any other form of power supply such as a battery, and as long as it's 5 volts, as long as you're talking a 5 volt supply, put 5 volts in there and it will put the right amount of voltage into the phone and charge it up. So let's pretend that we've got a 5 volt supply, something convenient, right, and we want to put power into our smartphone. So what I'm going to do is I'm going to hook up this HTC. This is just a micro USB cable and the phone's completely flat. And I'm going to put 5 volts into this USB plug using this external power supply. Okay, so what I've done here is actually cut the top off a micro USB cable, the one that I'll use to demonstrate charging of this HTC smartphone. Just cut the top off the cable so you can see inside there a little bit better. So as you're looking at a cable, Right, this is the top, and the bottom, if I grab another cable, the bottom of a USB plug always has the slit, so you can actually see the join. The join is always at the bottom. Two holes that are concealed is the bottom. The top is where the two holes you can see through, and there is no join in the metal. That's the top, and that's what you're looking at right here. As you're looking at the top of the cable, the one on the right is positive, the one on the left is negative or ground. They are a little bit longer than the two data pins in the middle. That's all you really need to know. So I'll demonstrate now by charging up this HTC. I do have it turned on, it has a bit of juice in there. So we can see 84%, right? And I will fire this up now and charge it just using a 5-volt external supply into this USB cable. So as you can see, I have got my external power supply just set on 5 volts, and I'll hook up positive, and I've got a bit of tape around this one, obviously because it's a metal casing and I don't want the positive and the negative shorting. I'll just make sure I get a good connection, and there you go. You can see that the phone is charging, and although a little bit clunky, you can actually tell that you can get into those connections on a USB plug, right? And you can actually charge up a phone using an external 5-volt power supply. Okay, so we can get 5 volts into our smartphone and put some power into it that way and get enough to either charge up the battery or to at least use it. So that's fine if you've got 5 volts hanging around, but 5 volts, unless you've got power from something else like a 5-volt USB port in a laptop or a 5-volt USB port in some sort of stereo or something else that's still got power whilst you're without power, 5 volts in that instance isn't much good to you. So what else can you do? Well, if you've got a car around, or you've been travelling, or you've got a vehicle parked downstairs or next door, whatever, and you've got one of these little units, these are simply your USB ports for a 12-volt power supply or old cigarette lighter in a car. So you can actually plug that into your car, and you've realistically got another USB port at 5 volts, and away you go, as long as your car's got battery power. So let's just double check what you get out of one of those, and we'll use one of those to charge up the smartphone here on the bench using the lab power supply to emulate 12 volts. Alright, so what I've got is the multimeter and the lab power supply putting out 11.9, 12 volts, and with these, the pin at the back is your positive, and the 2 pins on the side, either one, are your negative, and this particular one is rated at 12 to 24 volt input, so it's got a wide range of input. And this particular one has 2 USB outputs, one rated at 1 amp and one at 2.1 amps. That's kind of useful because if you've got a mini iPad or an iPad or any other tablet style device, 1 amp typically won't do it. You'll need at least 2.1, and that one's rated at 2.1 on the second USB port. Alright, so let's hook this up to our lab power supply. That hooked in the side there. Okay, so technically right there I have got 12 volts going through, but I've got 2 USB ports outputting 5 volts, and I can charge my smartphone off that. I've got a USB cable here that I use for little bits and pieces of different projects, and I'll use this one to get the positive and negative power reading from. I'll hook that up to the multimeter right now. Alright, so with the multimeter turned on and obviously set to volts, I should be getting a 5 volt reading when I plug this in. And there we go, 5.04 volts. So using a bench power supply to simulate a car battery, using one of these adapters, which is simply a step down converter, converting 12 volt power, stepping it down and putting out 5 volts, although quite a lot of amps, it's really quite handy. So going through there, great. We can plug in our USB cable and we can charge up our devices using a car battery. how low will these things actually go? And that is a question I've been wanting to find an answer to. So I'm going to wind down the voltage on the lab power supply and just see how long it takes before I'm not getting 5 volt reading out anymore. We already know this will go up to 24 volts and still provide 5 volts out, but I want to know how low it actually goes, because I think it'll cut off at around normally about 3 volts higher, so it should drop out at around about 8 volts, but I don't know, so let's find out. So leaving everything hooked up the way we had it, and you can see the multimeter there reading 5 volts, and I'm winding down the lab power supply. Okay, we're down to 11, still getting 5 volts, 10, 9, still reading 5 volt output. We're down to 8, now we're down to 7, and we're still reading a 5 volt output, although there's a slight fluctuation there. Alright, we're down to 6 volts, and yeah, we've dropped to 4.8. So as I would have probably expected with most of the step down DC to DC converters, there's about a 1.5 to 2.5 volt gap between what your input range can be and what your output range can be. So if you're asking 5 volts output, you have to be putting in around about 7 on average. Some, depending on the componentry, it varies slightly, but it's normally, ballpark figure 2 volts. So in this case, we'll drop it to 6, we can only get about 4.8 out. That might still power up. Certain devices are tolerant, but with a smartphone, tolerance is not that high. You probably want to get as close to 5 volts as you can, but we can actually try it. We'll plug in a smartphone now and see whether or not we can continue to get a power reading on the phone. Alright, I'll leave everything connected as it was except for the multimeter. I'm using a normal micro USB cable and the smartphone. Plug it in, and here we go, we are charging. Okay, there we go, still seeing it's charging, and I'll now wind down the voltage. It's still charging. I'm down to 7.9 volts, still charging because this is still putting out 5. Alright, now I'm down to 6.8. Alright, we're still putting out a charge. The device isn't really getting hot, it's probably only drawing about half an amp. Alright, I'm now down to 6, and it is still taking a charge through to the phone, but I drop into the 5 range. And this phone's fairly tolerant, so we're probably really only getting about 4.5 volts there. So if I keep dropping it, there we go, it's fluctuating, not doing the phone any good, not charging, and that's at 4.8 volts. Basically, might as well call that 5. At 5 volt input, it is still putting out enough voltage for this phone to recognise and take a charge, but obviously it's designed to run much higher than that. But what if you don't have a car? Having one of those, we've seen that very, very adaptable, 5 volts through to 24 volts to give you a 5 volt output, or at least close enough to get something running. So what if I just hooked up a 9 volt battery, don't have a car, but I've got a little 9 volt battery? Will that do the job? Okay, so here's our phone, here's our little unit, here's our USB cable, I've got a 9 volt battery. 9 volt battery, mark very clearly which one's positive. So I've got the negative, I've got the positive, and remembering the sides are negative on these devices, and the back pin is the positive. Alright. So from a 9 volt battery, I'm not getting anything. Okay, so everything's hooked up properly, right? But we're not getting the phone to charge. And there's a very simple explanation for that. A 9 volt battery by itself is probably good for around about half an amp, right? At 9 volts, that's about as good as it's going to get. The actual converter wanting to put out a 1 amp output at 5 volts, it's simply not receiving enough wattage. So although the voltage is enough, as we've seen on the lab power supply, it will run as low as 5 as long as there's enough current. with a 9-volt battery, there is just not enough. If this was a portable little 12-volt battery, then I would say we'd be fine. But a little 9-volt battery like that, no, not going to do the job. So what else can you do? Well, if we dispose of the 9-volt batteries, and we've still got our USB cable and phone, but we will retire this little car adapter. So you've probably got lots of other potential power supplies floating around the home, or you might have you know, some resources wherever you are for external power, but it's just not the kind of power that you want. As an example, here is a little 2 battery box, 2 1.5 volt AA batteries, and that's fine. That'll give you 3 volts and a fairly low amperage, but possibly more than what you'll get out of a 9-volt battery. So there is 3 volts. It's not enough to get into the phone, and obviously we can't just hook it up with a couple of wires dangling out. If you were really wanting to make sure that you had enough powering capabilities, or you're into a project or anything else, these little Pololu, this one's another Pololu one, these little voltage regulators, this is a step up, step down voltage regulator. They don't have to be this ornate. You can actually get voltage regulators that will step up a low voltage and give you 5 volts out off eBay for around about $2.50. They're great to have for just little hobbies, repairs, you know, fixing something that's broken down and you find out why it's a power issue. But they're also great just to have a couple of spares, throw one in your car, throw one in your backpack. So as long as you can get access to some form of power supply, potentially you can step it up enough to charge up a phone. So let's have a look at that. So there's the little voltage regulator that I was talking about. Marked on the back fairly clearly, ground and voltage out, ground and voltage in. The enable pin is to enable a higher amperage, but in this case all we really need is just the default settings. So ground voltage in, ground voltage out. So if we put our 3 volts coming out of this little battery box into this, can we actually charge up our smartphone? Let's have a look. So yep, here's our regulator, ground and voltage in. So that is the ground wire, and that is right below it, the voltage in. So as you can see there, we're getting an absolutely perfect 5 volts out on the multimeter. So is that enough to get our smartphone going? And what I might do is I might actually solder on a couple of wires onto this just to make it easier to demonstrate. Well, that won't win me any awards, but it's done. Let's hook this up to our power. So this is the positive coming out of the power regulator, and the negative. Okay, so in theory we've got 5 volts coming through our USB cable and into our smartphone, and there you go. Phone is charging from 2 AAs. So we're now charging our smartphone off 2 AAs and a little power regulator, something that you can buy off eBay for around about $2.50. So all you need to worry about with the power regulator, if you want one of those in your kit, or you want to keep a spare one of those lying around, is just make sure it's a step up power regulator. Obviously this pretty much works as a step down power regulator, takes a higher voltage and gives you 5 volts out. This one will take a lower voltage and give you 5 volts out. There are adjustable versions of those too, but they are very, very handy. Okay, so all that's great if you've got one of those little battery boxes lying around, but what if you don't have one of those? Well, if you're out hiking, camping, doing whatever, or you're at home, chances are you've got some sort of torch. Torches have batteries, so all you really need to do is try and get 5 volts out of whatever's hanging around in this. In this instance, this is just an old AA stand upright type torch. So if I just open up the head on that, as you can see, there's 2 dirty grey connectors. And with those, I can hook those up to my friendly little power regulator, step up, and I can get 5 volts out and charge my phone. Turn it on, and I am, once again, charging the battery. Okay, so we've covered off on a few options there, especially if you can get to a USB outlet or you can get access to a fixed 5 volt voltage supply, as well as what you can do if you've got a car handy. So basically just expanding from that, solar panels. Obviously solar panels are around about 12 volt output, but they do fluctuate up to somewhere around 19 volts. So if you've got something like that little car USB adapter that we talked about, you can connect that up to that because it'll take up to 24 volts and give you a 5 volt supply out. So they'll work great together. So having one of those handy is a very, very handy little unit indeed. So, and that's reading the output of the solar panel at the moment, only reading around about 8 volts, and that's because it's just using the lamp as a light source. So I could still feed that light source through that solar panel into this little regulator, plug in the cable and charge my smartphone. So dynamo, same sort of thing. It basically operates as a little torch and or a radio. So they use capacitors in order to be able to store the charge, to be able to power the device. You can get some juice out of one of those if you've got a dynamo powered charger. They make specific chargers dynamo powered, or something that's got a dynamo powered torch or radio. What if you don't have one of those handy little units, but you do have a 12 volt supply or a 9 volt supply, some sort of fixed voltage, say as a car, but your car doesn't have any USB ports, don't have one of those. Can you charge your smartphone from the car without one of those? Well, yes you can. Some vehicles have 5 volt supplies in other areas, not so much the speakers, but the back of the stereo unit has possibly got a 5 volt supply in there. And if you were going to make yourself a little kit that had something like a voltage regulator in it, there's something else that you can do that's much, much, much cheaper, and it's just called a voltage divider. You can take a 12 volt source and get yourself 5 volts out of that. I'll just show you how to do that now. So I think the easiest way to think of this is if you've got a 12 volts flowing through a circuit and you've got, say, 1 kilo ohm resistance. If you split the difference between 1,000 kilo ohms between 2 resistors and you split them evenly, it would evenly divide 12 volts, giving you 6 volts out. If the first resistor is slightly higher by percentage than the second resistor, as an example, if we were talking 1,000 ohms resistance, one was about 680 and the other one was around 320, the difference out of that is not exactly equal, so it's going to be a lower voltage because the first resistor is higher than the second. Well, let's just have a look at that and we'll see if we can emulate that here on the bench. So I'll run our 12 volts into the first resistor, and I'll run the first resistor into the positive power rail, so that's our 1 kilo ohm, just in there. I'll then run the second resistor out of the positive, and I'll run it down to ground on this little breadboard, and I'll use a small jumper to connect the power supply to ground. Okay, so in this instance we actually have 12 volts coming through this resistor, which is going into ground, and this is connected to ground. So we have ourselves a little circuit with 2 resistors in the middle of it. One 1000 ohm, one 280 ohm. As a rough pluck, I would probably say we're going to be getting probably around about 3 volts. So this is our voltage divider output right here. And there we go. Through that particular voltage divider, having 12 12 volts coming in, 1 kilo ohm on this side, 270 ohms on this side. The difference via percentage of between the two is the output value, and in this case we're getting 2.56 volts. So all you need to do is work out the value. You've got a fixed 12 volt power supply such as that in a car, 12.7 volts, and you know that your phone can tolerate somewhere between 4.75 and 5.25 volts as an input. You can actually work out just using two little resistors like that and some wire how to get 5 volts out from a 12.7 volt power supply like what you would find in a car. That is also handy for 9 volt supplies or two 9 volt batteries giving you 18 volts. It's also handy for the varying outputs of dynamo powered devices if they're not already set up to charge phones. So in general, having a little voltage divider circuit and a couple of resistors lying around can really be handy. So that's all I really wanted to cover off on this video. Hopefully it didn't go too long. But yeah, there are a number of ways when the power goes out or you don't have your wall adapter, how you can actually get some power into a smartphone. So hope you enjoy that, and thanks very much for watching. So thanks very much for joining me and watching the show. Subscribers are always welcome, so feel free to subscribe, that would be great. And I hope you'll join me again next week.